So next up, we have Aubrey Duggar, and Aubrey's going to talk to us about a new national water model, and does a lot of work with the water, so I'm excited to hear what you have to say. Thanks.
Do a lot of work with water. Thanks, Terry. Okay, so I am going to introduce you to the NOAA's new National Water Model. This is a collaborative project between NOAA's Office of Water Prediction and NCAR here in Boulder. And the first question you should be asking is, why do we need a national water model? So for those of you who have watched the news anytime over the past year and a half, some of these images might look familiar. Floods, freshwater floods in the US account for on average about $8 billion and 82 lives lost per year. Now, the current forecasting system for dealing with water forecasts looks like this. The National Weather Service operates 13 independent river forecast centers around the country that are responsible for making predictions at about 3,600 discrete locations. Now, the new paradigm instead is a single integrated model that's making continuous predictions at 2.7 million river reaches across the US. Now, our goal here is to shift sort of water prediction into the realm of weather prediction. So we want everyone to be used to looking at water predictions, water forecasts, the same way they're used to looking at weather forecasts, anywhere out from the next hour to 30 days into the future. Now, obviously, a modeling system like this generates a lot of data. We're generating about 3 terabytes per day of data. Just to give you a sense of scale, that's about half of the entire content of Wikipedia, or I recently learned about 15 minutes of people posting cat videos on Facebook. So what do we get for this 3 terabytes per day? Well, we get a continuous picture of different water states across the country. So these are things like soil moisture, snowpack, inundated area, and we get this from now out into the future. So let's see if this slide, may or may not work. There we go. All right, so we also, of course, get streamflow prediction. This is an animation of about 3 weeks during last May. You'll see these weather systems moving across the country and that propagating down to flood waves moving down the river system. Now, whenever I introduce this model, the first question I always get, it looks like I killed the advancement, sorry. So I'll flip ahead. We're back to 15 seconds now, I swear. The first question I always get is, how good is the model? And I always like this quote because it's very accurate. All models are wrong, but some models are useful. So I'm going to walk through 3 different examples of where we think this modeling system will be useful. The first is this flood that impacted Hartsville, Tennessee in May of this past year. And this happened in what we consider a hydro-blind area, meaning there are no gauges or no forecast points in this region, so we really didn't have a lot of advance notice that this flood was happening. You'll see that orange region on this hydrograph, so that's the stream flow. That orange region is when floods were actually observed. And you'll notice that red line, that's when the very first watcher warning was issued for this region, and it's already partway into the flood event. The blue line you'll see on there is what the water model would have predicted with about 8 hours advance notice. So we think with this model in place, we would have had more time to get folks out of harm's way. The next event is also a flash flood, but over a much larger scale. This is what Texas looked like during Memorial Day weekend of last year. And you can see this is a huge weather system dumping a lot of precipitation on the entire state. Now, with an event of this size, it's really difficult to predict exactly where a flood is going to occur. The River Forecast Center actually did a really good job with this event. However, they gave folks lots of warning, but these are pretty general warnings covering large areas. It's really hard to get specific on impacts until we're into the event. So the town of Wimberley took the brunt of the event. This was a flood that hit the Blanco River from a bunch of rain that dumped upstream. This is actually a hydro-rich area. So you'll see those black points on the plot. This again is a hydrograph. That shows the river stage during this event. It went from 7 feet to about 42 feet within 4 hours. That's an astronomical amount of water. Now, while none of the modeling cycles got it perfect, with our modeling system in place, we would have been able to prevent somewhere from a moderate to very important flood happening from 12 to 6 hours ahead of time. Now I'll take us to something from this past weekend for my last example, a hurricane. Now we obviously get a lot of notice on hurricanes. These are slow-moving systems. It's easy to kind of predict where we think floods are going to occur. But another product that's coming out of this model is a more detailed picture of where we think inundation is going to occur. So those red and orange areas on their map are where we're predicting inundation in the city of Charleston. So you can imagine taking information like this, piping it into an app, and if you're trying to find an escape route, being able to have your tool navigate you around potentially risky flooded areas. So with those 3 examples, we think this model will be really useful. This is a very new modeling system, just went into operations this past August. So I encourage you, we are constantly evolving the products coming out of the model, and the model itself is constantly evolving. So I encourage you to check out water.noaa.gov for more information. Thank you.